So if a car is moving down a highway at 35 meters per second, and the car has a mass of 1,200 kilograms, how large, let's say the car hits a barrier, how large is the force if it hits a barrier, crumples, stopping in 10 seconds. Okay, so here's our question. We'll do 2 examples with impulse. So in the impulse, we talked about initial and final momentum. So we have to define what is our initial and what is our final situation. What do we mean by those two? Well, the initial is when the object hits that barrier. So when the car hits the barrier, okay, and the final is when the car stops. So here's my car, it's moving, it's our barrier, here's the car, and it's just sitting there. All right, so we know that there is a mass initial, which is 1,200 kilograms, and an initial velocity, which is 35 meters per second. As I've drawn it, that is positive. I've drawn it to the right. Remember, momentum has direction. So it's to the right. And the mass of the car did not change, but the final velocity is equal to 0. It came to a stop. And we know this happened over 10 seconds. So our impulse is equal to our change in momentum, which is equal to our force times our time. So our final momentum minus our initial momentum equal to our force times our time. Final momentum is 1,200 times 0. So that goes away. Minus 1,200 times 35. Oh my gosh, I don't know. Oh, yes, I do. But you guys have calculators. Equals the force times 10. So, yeah, 1,200 times 35. So negative 42,000 is equal to my force times 10. So negative 4,200 newtons is equal to my force. It's important to note that negative. That tells us that the force is acting to the left. Does that make sense? Is that evaluation piece? Well, the car was moving to the right. If the force is acting to the left with the car moving to the right, it's slowing down. And indeed, it's coming to a stop, so it's slowing down. Questions on that?